We've found almost 6,000 planets orbiting other stars. And here's the thing almost nobody tells you. We've barely seen any of them. Nearly every exoplanet you've ever heard of was never actually photographed. We detected it indirectly, a tiny wobble in its star, or a faint dimming as it crossed in front. We inferred the planet. We never saw it. It was always a number in a graph, not a thing in a picture. In June 2025, that changed in a small, specific, and genuinely historic way. The James Webb Space Telescope pointed at a young star 111 light-years away and took an actual photograph of a world we'd never seen before. A faint dot of infrared light. A real planet caught in the act of existing. And the strange part isn't that we got the picture, it's which planet showed up. To understand why this is hard, picture the problem. A star is a searchlight. A planet next to it is a candle. From across the galaxy, you're trying to photograph the candle while someone shines the searchlight directly into your lens. That's why the few planets we have directly imaged are all the same kind. Enormous, blazing hot young Jupiters, far from their star, still glowing from the heat of their own formation. The easy targets, the cosmic equivalent of bonfires standing well away from the searchlight. To get this image, Webb used a device called a coronagraph. Basically, a precisely shaped mask that blocks the starlight, like holding your thumb up to cover the sun. With the star's glare hidden, the telescope could finally pick up the faint infrared heat of what was hiding beside it. And what was hiding beside it broke the pattern. The planet, TWA-7b, isn't a giant. It's about the mass of Saturn. That makes it roughly 10 times lighter than any planet we'd ever directly imaged before. We didn't photograph another bonfire. We photographed something closer to the size of a planet in our own solar system. Now I can hear it. It's one fuzzy dot. That's not a photo of a planet, that's a pixel. And you're right that it's not a postcard. You won't see clouds or continents. But here's why the dot matters more than a pretty picture would. Every other way we find planets, we're measuring the star and deducing the planet exists. This is different. This is light that left the planet itself, crossed 111 light years, and landed on a detector. We're not inferring it anymore, we're looking at it. That's the line this crosses. And there's one more thing that turns this from a lucky snapshot into real science. The young star is wrapped in a disk of dust and debris, the leftover rubble of planet building. And in that disk, there was a gap. A clean ring swept empty. Theory has said for decades that a planet orbiting inside a disk should act like a plow, its gravity clearing a lane as it goes. When Webb found the planet, it found it sitting exactly inside that gap. The plow caught next to the lane it had cleared. We didn't just photograph a world, we caught one in the act of shaping the system being born around it. Here's what I keep coming back to. For all of history, another world was an idea, a point of light, a line in a dataset. Even as we counted them into the thousands, they stayed abstract, statistics, not places. This is a place, a specific world, about the size of Saturn, circling a young red star 111 light-years away, slowly carving its lane through the rubble of a solar system that's still forming. It was there before we looked. It will keep going long after we stop. And for one moment, a telescope 1,000,000 miles from Earth caught the faint warmth of it and turned it into an image a human being could look at. We've spent decades proving other worlds exist. This is the quiet, almost unremarkable moment where we stopped proving it and started seeing it. And TWA-7b is the lightest one yet, which means the technique is getting more sensitive. The bonfires were first, now we're reaching the Saturns. Give it time and the targets get smaller and colder and more familiar, until one day the dot we're squinting at is the size of Earth, around a star we can point to. That's not a fantasy, that's just this same method a few steps further along. So here's my question for you. We finally have a real photograph of another world. When we eventually get a direct image of an Earth-sized planet around a sun-like star, the thing this is the first baby step toward, what's the one piece of information you'd want from it most? Tell me below, I read every comment. And if you want to be here when that picture comes, subscribe, because the telescopes that take it are being pointed right now.